today we have an integral involving the floor function, which is the integral from 0 to infinity of the floor of x over x to the k with respect to x. So as with a lot of floor function questions, the first thing we're going to do is convert this into a sum from 0 to infinity of the integral from I to I plus 1 of I over x to the k dx. Now I is constant here, so we can integrate this function, and this will be the same as the sum from 0 to infinity of I times x to the minus k plus 1 over minus k plus 1 from I to I plus 1, which when we plug in those bounds becomes the sum from I equals 0 to infinity of I times I plus 1 to the 1 minus k over 1 minus k minus, put this all in brackets, I to the 1 minus k over 1 minus k. Now we can take out a common factor of 1 minus k, and then we can expand these brackets and write them as two separate sums. So this becomes 1 over 1 minus k times the sum from I equals 0 to infinity of I times I plus 1 to the 1 minus k minus the sum from I equals 0 to infinity of I times I to the 1 minus k. Now we can do the reciprocal of this if we change this to a k minus 1 instead of 1 minus k. So this becomes over I plus 1 to the k minus 1. And we can do the same thing here and turn this into a k minus 1. So over I to the k minus 1. And what we see here is that if we plug in 0 into here and 0 into here, we'll just get 0 as our first term. So we can just rewrite this as a 1 and this as a 1, and it'll be the same as changing nothing. And now this is the same as, we keep this, and we're going to re-index this integral, sorry, this sum. So if we replace all the i's with I minus 1's, and then start at I equals 2 instead of I equals 1, this will be the same sum. So the sum from I equals 2 to infinity of I minus 1 over I to the k minus 1. Subtract the sum from I equals 1 to infinity of I over I to the k minus 1. Now we see that if we plug 1 into here, we just get 0. So we can in fact change this to a 1 so that these two are the same. So now we can combine this into one sum, and we can take out a common factor of I to the k minus 1 as a denominator. So this becomes the sum from I equals 0 to infinity of I minus 1 minus I over I to the k minus 1. Now we see that the i's will just cancel out, and so this becomes 1 over 1 minus k times the sum from I equals 0 to infinity of minus 1 over I to the k minus 1. Now we know that the Riemann zeta function of some number s is just the sum from I equals 0 to infinity of 1 over I to the s. And so we see here that this is the same as this, but where s equals k minus 1. And we also see that we have a negative 1 here, and so if we times this fraction by negative 1, we can just flip the order and turn this denominator into a k minus 1. So this will become 1 over k minus 1 times the Riemann zeta function of k minus 1. And then we're done. That's all for this video. Thanks for watching. If you have any questions or video suggestions, leave them in the comments below, and if you want to see more content like this, subscribe now.